Moist air rises from the Pacific Ocean. I got a little image over here to illustrate that. If this is our Pacific Ocean, it hits, this is, whenever it hits a mountain, that moist air has to be lifted upwards. And anytime you take warm, moist air and lift it higher in the troposphere, it starts to cool down, and it eventually will hit that dew point temperature where it condenses. Again, cold air can't hang on to moisture as easily as warm air can closer to the surface. And so it condenses to form clouds, and then you'll have precipitation on one side of the mountain range. If this was the Sierra Nevada mountains, these will be the valleys in California that get a lot of rain. And as it goes over the top of the mountain and it starts to sink back down, well, it's very dry air because it lost all its precipitation on the western boundary of that mountain. But also, as it sinks back down, just like it cools when it rises, it also warms up as it sinks back down. And that dry air that's now warmer as well, it can start to evaporate more because warm air can hold more moisture than cold air can. And so not only does it not rain on this side, but any moisture that you might have is going to become evaporated. So you'll usually find deserts on on the eastern side of this rain shadow effect. And so deserts on the west side, rains on the east. We got heavy rains on the west. Yeah, let's see here. Deserts. There we go. That's the one we're looking for. So again, this is called the rain shadow effect. It can also be called orographic uplift. An orogeny is a mountain building event. And so orographic uplift or mechanical uplift is another name that they use for this, because instead of the air just rising on its own, it's being forced upwards by an object. And so sometimes they do call that mechanical uplift as well.